All right, so these are just additional problems that I found fun. And so all of these problems are going to have the same thing. Let's find all solutions in radians. All right, so these are a little bit different than the ones that we were dealing with. So again, I find them a little fun. So theta plus pi over 4 is equal to 1/2. Okay, so again, this kind of looks challenging because you're like, ooh, theta, but we're adding a pi over 4. So again, I'm going to write a let statement. I'm going to get rid of what's weird and unusual. So I'm going to say let x equal theta plus pi over 4. So this is now to become sine of x is equal to 1/2. So again, I know that it'll be the first and second quadrant. So this will be your pi over 6 and 5 pi over 6. So when I come up with my equations, two equations, so x is equal to pi over 6 plus 2 pi n. Here's my second equation, x is equal to 5 pi 6 plus 2 pi n. Again, I'll replace the x with what I originally had it with. So this would become theta plus pi over 4 is equal to pi over 6 plus 2 pi n. And then theta plus pi over 4 is equal to 5 pi over 6 plus 2 pi n. So again, it looked challenging, but notice that instead of multiplying or dividing, I'm just going to be subtracting. So I'm going to subtract pi over 4 to both sides. I'm going to make it become a denominator of 12. So pi over 4 is really 3 pi over 12, and pi over 6 is really 2 pi over 12. So this will become 2 minus 3. So theta, so 2 pi over 12 minus 3 pi over 12, and then again plus 2 pi n. So this is really theta is equal to negative pi over 12 plus 2 pi n. Do the same thing over here. So this will become theta is equal to, and this will become 10 pi over 12 minus 3 pi over 12 plus 2 pi n. So theta is equal to 7 pi over 12 plus 2 pi n. So we have one equation right here and another equation right here. My pi looks like a 25. So let's write that a little bit better. There you go. So it gets a little bit different, a little new. So using that knowledge, why don't you try the second example? Again, same directions. So this time it's cosine of x minus pi over 3 is equal to negative 1. All right, so if you pause the video and you tried this on your own, let's see what happened. So again, I'll write a little let statement. Let's let theta equal x minus pi over 3. So this is really the cosine of theta is equal to negative 1. There's only one answer. Theta could be, and it's pi. So again, I'm going to say theta is equal to pi plus 2 pi n. Replace my theta. So x minus pi over 3, pi plus 2 pi n. Add pi over 3. So x is equal to 3 pi over 3 plus pi over 3 plus 2 pi n. So 4 pi over 3 plus 2 pi n. So that would be our equation to find them all. All right. Let's try one more. So again, pause the video. This one's a little bit more challenging. What about sine of 2x minus pi over 3 is equal to root 3 over 2. Again, find all your answers in radians. Go ahead, pause that video now. All right, if we're coming back from an unpaused video, this is how I would have set this problem up. I'm going to let theta equal 2x minus pi over 3. So this will become sine of theta is equal to root 3 over 2. Okay, I'm looking at quadrant 1 and quadrant 2. So in quadrant number 1, I have pi over 3. In quadrant number 2, I have 2 pi over 3. So my first equation will look like this. 2x minus pi over 3 is equal to pi over 3 plus 2 pi n. Second equation, same thing, except for it'll say 2 pi over 3 plus 2 pi n. I'm going to add pi over 3 to both sides, so 2x is equal to 2 pi over 3 plus 2 pi n. I'm going to multiply by a half, so I'm going to get pi over 3 plus pi n. For that first one, do the same thing over here, so add that. So I'm going to get 2x is equal to 3 pi over 3 plus 2 pi n. Those cancel each other out. So we just have 2x is equal to pi plus 2 pi n. Divide by 2. X is equal to pi over 2 plus pi n. So again, anytime you see something inside parentheses, write a quick little let statement, get rid of it so you can figure out what it's going, what an easier problem is. And again, most of our answers are from the unit circle. Sometimes they are not, but most of the time they are.